Hey guys, in today's video we are going to discuss about the memory management, which is one of the most important chapter from the operating system. So let's start the video. Memory is central to the operation of a modern computer. Memory consists of array of words or bytes, each with its own address. Memory has its own address. The CPU fetches instruction from the memory according to the value of PC. That means program counter. This instruction may cause additional loading from and storing to the specific memory address. As we know that memory has its own specific address, the CPU fetches the instruction from the memory according to the value of program counter, and CPU. These instructions which are loaded from the program counter are cause additional loading from the storing to the specific memory address. Now let's explain about the monoprogramming. In monoprogramming, memory contains only one program at any point of time. In case of monoprogramming, when CPU is executing the program and IO is encountered, then the program goes to the IO device. During that time, CPU sits at idle. In monoprogramming, CPU performs only one program, but if there are two programs, that is one execution and another IO performance, at that time the CPU goes to the IO and programming goes to the IO devices. At that time the CPU sits as idle. Hence, in monoprogramming, CPU is not effectively used. The CPU consumption is poor and the utilization of the CPU is poor. In monoprogramming, most of the memory capacity is dedicated to a single program. We know that monoprogram contain only one program, so the memory capacity is dedicated to a single program. Only a small part is needed to hold the operating system. Only a few parts is needed to hold the operating system. In monoprogramming, whole program is in memory for execution. When the program finishes the running, the program area is occupied by the another program. Suppose this is a memory which contains a running program. If this program is finished and the another program occupies that space. Monoprogram consists of the three variations as in this configuration first. Suppose this is configuration first, this is configuration second, and this is configuration third. In this configuration, operating system is in RAM below the user program. In portion of RAM above operating system, there may be a user program. In second concept, operating system is in ROM and below the operating system there is user program. In third portion, device driver may be in ROM and operating system is in RAM, but user program may lies between device driver and operating system. This is the three variation of monoprogramming. Let's explain the above configuration. The operating system may be at the bottom of the memory in RAM. The operating system may be at the top of the memory in ROM in figure configuration second. The device driver may be at the top of the memory in ROM and rest of the system in RAM lies below the device driver. Let us take an example of a memory. Let's take an example of monoprogramming. Batch processing in old computers and mobiles. The old operating system of computers, mobiles, and so on. The mobile operating system. What are the features of monoprogramming? Guys, I will put this note in my website, but the website is under construction, so stay conscious and stay tuned. I will update there. It allows a single program to be present at any memory in any time. We know that the monoprogramming consists of a single program to be present at the memory in any time. The resources are provided to a single program. The resources are provided to a single programming that is present in the memory at that time. The resources are provided to a single memory in the same time. Since only one programming is loaded, the size is small as well. The size of monoprogramming is comparatively small than the multi-program. Let us take an example. Given that the size of a memory is 64 MB and the reserved part for the operating system is 4 MB, what is the maximum size of program that can be run in the memory? Let us elaborate this by using figure. The total size of memory is how much? 64 MB, and this portion is attenuated for the operating system, that is 4 MB. What is the remaining programming? The remaining programming is the maximum size of programming is this, that is 64 minus 4 MB is equal to how much? 60 MB. So 60 MB is the maximum size of program that can be done. And here is another example. Average time required to run a certain programming is 10 microseconds to access the CPU. Average need is equal to 70 microseconds to access the IO devices. What is the percentage of how much time does the CPU remain idle? We know that if the CPU remain idle, it consists of total time to the access CPU upon in monoprogram. The CPU goes to idle when the program goes to the IO device instead of going to the CPU. The time taken for the CPU idle is time taken for the IO device upon total executable time. That is, total executable time is 1070 plus 10, that is our 87.5%. So guys, this much for today. Hope you enjoy this video, and this is one of the most important topic from the operating system. And if you like the video, please subscribe our channel and share this video with your friends. Thank you so much. Thanks for watching.